So what we're going to take a look at today is an easier way to actually find the solutions to a quadratic equation of the form y is equal to ax squared plus bx plus c. Now, every time we're looking at that equation, we call that thing the standard form of the equation, right? So that's like the expanded form. Okay, we've studied that. We've done that several times. We just never really gave it a name. Now, anytime we're looking at an equation that looks like this, ax squared plus bx plus c is equal to 0, all that means is what we've moved all of our variables and letters and numbers to the left side or the right side. And what we're going to do is, instead of going through the factorization, because sometimes our factors don't work, we need to be able to calculate it very easily. Now, I'm going to zoom in on the most important thing for today. Remember, this equation is based on these two things. For a, x squared plus bx plus c, so that's where you have an equation where the x squared term has a number on it. You have a bx term, and you have a c. And this here represents the most important equation that you'll learn in mathematics, because sometimes you forget how to factor. Sometimes you can't find two numbers that multiply to something and add to something. This is how you go about solving it. Now, the most confusing thing in this entire equation is this thing here. Okay, notice how I'm highlighting it. This thing here is called the discriminant. Now, you know that with something that is square rooted, right? You know that if it's a negative underneath the square root, you can't calculate it. Your calculator breaks, right? So this yields to three different things for this thing that we call the discriminant. Remember, this part here underneath is called the discriminant. Now, the reason why it's called the discriminant is because it helps us separate what happens with our graph. It actually tells us whether the graph is above the x-axis, touching the x-axis, or below the x-axis, depending on which orientation you're using. So now let's go over what all of this means for b squared minus 4ac. This is the most important part, and then we'll come back and we'll talk about this and how we use it. So on your printout that I've provided for you, we have an entire column that is going to talk about the discriminant, right? So here is what the discriminant is. So let's say I have b squared minus 4ac being bigger than 0, okay? In English, we say the following. We say that the number of roots or the number of solutions is equal to 2. So there's two possibilities, right? You could also say the X-Intercepts for this thing is also equal to 2. So now, what does that mean pictorially, right? So if I had a parabola, let's say we have a red parabola opening up and a green parabola opening down. So if we have b squared minus 4ac, we calculate it. That means that the parabola is either opening up and touches the x-axis at two key points, here and here, or it's opening down and touches the x-axis at these two key points. It's roots. That's all it means. So now let's go and do the next possibility. So if the b squared minus 4ac is bigger than 0, that's what we have when our parabola is either opening up or down. It touches in two spots, or it has x-intercepts, or it has two unique solutions. pause and copy this down. So now, if we have b squared minus 4ac equaling 0, it means that the number of roots, solutions, or x-intercepts is equal to 1. Now, pictorially, what the heck does that mean? Well, here's what's actually happening with your parabola. The only time a parabola just has one root is when it just touches the x-axis at one place. So for a red parabola, it would mean our parabola would open up and its vertex would touch the x-axis. If it was the green one that opens down, it would open down, but it would just touch the x-axis at that point. So it just sits on the x-axis. Okay. All right. Now you've seen equations like this. So that would be something like this. Y is equal to x minus 3 squared. So that would be something like this. That's it. There's no y value that moves it up or down. It just stays on the x-axis. That is when you have our solutions of 1. Okay. Now, imagine if we have our b squared minus 4ac being less than 0. This is what's actually happening. In English, this is what we're saying. We're literally saying that there are no roots, there's no solutions, and there's no x-intercepts, right? So what does that really mean pictorially? Pictorially, it looks like this. We have a parabola that's either opening up that doesn't touch the x-axis, or it opens down and doesn't touch the x-axis. That's it. That's all it is. And now on to our problems for the day. So now that you understand what the discriminant's all about, what the heck does that plus or minus thing mean? It actually means that there's a possibility of 2 solutions for every parabola, and that's because of the square root property that we studied in lesson 3.5 for quadratics, parabolas. Okay, now this accounts for that with that plus or minus square root thing there. Okay, now when we use this, we're going to use this with simple equations, right? So right now we're going to do some sample easy equations where we actually have to do the calculations. Now, the way we're going to do this is instead of doing this entire equation that we have here right away, what we're literally going to do is we're going to go and first find b squared minus 4ac, because we don't want to do it all on the calculator at once. We want to be able to identify whether we have 0, 1, or 2 roots. Okay, so now the first thing that we're going to do with this basic equation that we have here, 3x squared plus 5x minus 2, is we're going to have to take a moment and make sure that we identify the a, b, and c terms in our equation. So I'm going to write those in red. So a is on the x squared term, b is on the x term, and c is the constant term. Okay, so that means for our equation, we have the following. For b squared minus 4ac, we do our calculation. So that's equal to, well, 5 squared minus 4 times 3 times negative 2. So we end up with 25, and then we take this entire block, negative 4 times 3 times negative 2, multiply them together, and you end up with positive 24, which gives us 49 when we add them together. So that means b squared minus 4ac is equal to 49, which is greater than 0, which means that there are 2 roots. You could also say 2 solutions or 2 x-intercepts. It doesn't matter what you use for that. Just tell me what the b squared minus 4ac is telling us. So now that we have that, we can take all that information that we have here, our a, b, and c, and plug that into our equation. And since we've already calculated this b squared minus 4ac, we just have to plug it directly in. So we substitute directly into our quadratic equation. So that's why we're going from here to here. So now you end up with x is equal to, well, here is our solution. We have negative, notice I'm putting my stuff in brackets, 5, plus or minus the square root of 49. Notice I'm putting it in green to highlight it. Then divided by 2 times the bracket of, well, a value was 3. Now, let's simplify the top. Now, to do that, we're going to go and zoom in on this problem here. So we have negative 5 plus or minus 49. So these are the steps that you have to follow. Basically say, well, negative 5 is just going to be negative 5. And then we go plus or minus the square root of 49. Punch that in your calculator, and you end up with plus or minus 7. And then we divide by, well, 2 times 3 is 6. Now, our overall problem is going to split up into 2 separate solutions. And this is what we do. We take this problem and we split it up because, remember, with our parabola, we have 2 possibilities mostly for everything. All right, so now when we split it, we're going to have a problem that looks like this, and a problem that looks like this. We have x is equal to minus 5 plus 7, and then we divide it by 6, or our solution is x is equal to negative 5 minus still 7 divided by 2 divided by 6 again. Now, so now what we're going to do is we're going to go and devise our solutions. So here's what we do. So for this left side, so we'd go and solve for it. And what we're going to end up with is negative 5 plus 7 is 2 over 6. And that is x is equal to 2 over 6. When we simplify, you're going to get x is equal to 1 over 3. So that is our first solution. Okay. Now our other solution is x is equal to the following. X is equal to negative 5 minus 7 is negative 12 over 6, which means x is equal to negative 2. Now that I've got that, you would say the solutions are x equals 3 or x equals negative 2. And that's it. So we could say the solutions are negative 2, the x-intercepts are negative 2, or the roots are negative 2. Now let's move on to our next problem. So our new problem deals with irrational roots. So these are anything that has something like a square root in it for this type of problem, okay? Now, here is the problem that we're working on. It says solve the quadratic equation x squared minus 3x equals negative 1. Great. And we're going to express that answer as exact roots and then as approximate roots. So let's go through the solution for part A, the exact roots. In order to do that, we have to take our original equation, x squared minus 3x equals negative 1. And what we're going to do is we're going to take all the stuff that is on one side and move it over to the other. So we have to take the minus 1 and make it look like this ax squared plus bx plus c equals 0. Okay? So in order to do that, what we're going to do is we're just going to move that -1 to the other side. So we're ending up with this. X squared minus 3x plus 1 is equal to 0. Now remember, to use this great equation that we have here, this is our second part of our problem. We're going to use the quadratic formula to eventually solve this, right? And that requires us to have x squared is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Now, here is what we know based on our original equation. X squared is equal to negative 3x plus 1 equals 0. This is where our a is, this is what our b is, and this is what our c is. Okay? Now, a for this first, for x squared is equal to 1. B is equal to negative 3. And c is equal to positive 1. Now let's go and find the first, the discriminant, b squared minus 4ac. Substituting, you get the following. And now simplifying using BEDMAS, ends up being 9 minus 4. So b squared minus 4ac is equal to 5. So when you're having a doubt, I want you to go refer to our chart that we created earlier. You take a look. If b squared minus 4ac is greater than 0, in this case, our number is 5. That means we have two solutions. So we have something that looks like our picture there. And back to the problem. So now you're just going to say there are two solutions because our b squared minus 4ac is bigger than 0. So now what we're going to do is we're going to get the exact solution by substituting into our problem, our equation, which is located right here. Now that we have our substitutions, we need to make sure that we simplify this part here and this part. So now x is going to be negative 3. Negative of negative 3 is positive 3, plus or minus the square root of negative 5, of 5, divided by, well, 2. Now that we've got that, our problem splits into two possibilities for the exact solution. And that is this. I'm writing this in black now to emphasize it. So we get x is equal to 3 plus root 5 divided by 2, or x is equal to 3 minus root 5 divided by 2. Okay? And that is what you would call the solution, the X-intercept. But this is, more specifically, we call this the exact solution for our problem set. Okay, so our solutions are these possibilities. X is equal to 3 plus root 5 over 2 or 3 minus root 5 over 2. And those are exact solutions. Now, for part B, here's what you do. Just plug that into your calculator. 3 plus root 5, hit enter, then divide by 2. And we have for our approximate roots 2.62, or x is equal to 0.38. And we're done. Now for this problem, imagine you have exactly one root, right? We're going to solve this equation here. One root means our parabola is literally going to touch the x-axis, but on its vertex, or opening up or down, one of those two. This equation is a parabola that opens up. The a, b, and c values are shown here. So let's go through the whole solution and get to our final thing. So we have our calculation for b squared minus 4ac. You punch that into your calculator and you end up with b squared minus 4ac equaling 0. And since it's equal to 0, therefore there's one root or one solution. So let's go and substitute into our equation. So remember, with the quadratic formula, this is what we use. Negative b plus or minus b squared minus 4ac over 2a. Now we substitute everything we know. So when you substitute, you have something that's peculiar. The square root of 0. The square root of 0 is 0, so it's just gone. So now when we simplify, we end up with x is equal to 20 over 8. When we simplify, we end up with our solution being x is equal to 5 over 2 for our final solution. And that's it. We're done. Therefore, the solution is x is equal to 5 over 2. And you're done. Now, that brings up something that is peculiar. You know that our maximum or minimum for our parabola occurs at the vertex. So that gives us something peculiar to work with. And we'll look at that as the very last example of the day, because we have 2 more examples to do. So when you hear of the concept of no real roots, that means we have a problem. Danger, Will Robinson. There are no solutions in this case. Okay? So that sometimes happens when we're doing our calculations. So that means our parabola looks like this. Either the red parabola is opening up and above the x-axis, or the green parabola is opening down and below the x-axis. So it never actually touches the x-axis and has a root. So when you do a problem like this, this is the best type, because all we do is this. Identify our A, B's, and C's. So here's our A, here's our B, here's our C. In this case, because we have nothing on our x value, A is 1. Now let's substitute. Go through our calculations again. So 1. So we go and put in b squared minus 4ac. You do your calculations. So you got 4 squared minus 4 times 1 times 7, which is 16, and then minus 28. Ugh, that doesn't look good. So that's negative 12. So we end up with negative 12. So we're just literally going to say the following. Therefore, b squared minus 4ac is less than 0. So there's no solution. So there's no solution. And guess what? We stop. We don't do anything else. We're done. We do not pass go. We do not substitute into our quadratic equation. We are done. So, for example 5, I want you to remember this, that the quadratic equation gives us the roots of the quadratic, right? And also, sometimes it gives us the axis of symmetry. And that occurs when we have one real root, right? Now, if I ever simplify something like that, the basic equation to find the axis of symmetry is going to be this equation right here. X is equal to negative b over 2a for any equation that is in the form ax squared plus bx plus c is equal to 0, okay? Now, if we wanted to find the x-intercepts, okay, the first thing that you're going to do is you're going to take the equation 2x minus 5x minus 12 equals 0. Now, you need to remember that the original equation was y is equal to 2x squared minus 5x minus 12. That was the original graph, right? So what we're looking to do is find the x-intercept. So that's why we have this equation right here. 2x squared minus 5x minus 12. So now what we're going to do, imagine we go and do our factor by grouping or our Berry method to solve. So that's how we're going to do the x-intercept problem. And now we'll do our factoring by grouping. Just copy down what you see. So now let's look at the solution for the x-intercepts by using factoring by grouping. You'll notice that when you do this problem, you have to identify basically two numbers that come about from the multiplication of 2 and negative 12, which gives us negative 24. So that's where this part comes in. And then they must add to positive 5x. Okay? And the only two numbers that work like that are going to be negative 8 and negative 3. So we use our factoring by grouping. So we take half of our equation, put into the first bracket, half of our equation, and put it into the second bracket. And that's where we get this. These two separate brackets with a plus in between them. Now, once we've done that, we're looking for a number that is divisible for both equations, in the first bracket and the second bracket. The first bracket, you're pulling out a 2x. The second bracket, you're pulling out a minus 3. And based on that, you're going to get x plus 4, 2x minus 3 equaling 0. And then what we do is we solve for the x's. So for this one here, for this problem here, we've literally taken our x value of x is negative 4 and found positive x plus 4 and found to be x is negative 4. And then we solve for this one as well. And we get x is 3 over 2. So you set 2x minus 3 equals 0, solve, get 3 over 2. Do the same for x plus 4, solve, and you're done. Now, let's move on to the meat and guts of what we were looking at today. What we're looking to do is we're looking to find the axis of symmetry for basically this equation right here. Y is equal to 2x squared minus 5x minus 12. No, it should be plus 5x. Let's fix that. Okay, so now remember our equation for the axis of symmetry is given by x is equal to negative b divided by 2a. So let's go and identify the a, b, and c on our equation, a, b, and c, and we substitute directly into this equation. So now we get x is equal to negative 5 divided by 2 times 2. So we end up with negative 5 over 4. So that is our axis of symmetry, the AOS. Now, you know that if you have the AOS, you can substitute that back into your equation to find the vertex, the y value of the vertex especially. So let's do that. So we're substituting x is equal to negative 5 over 4 into the equation. And this is what we get. So you end up with these two extra lines. And now we will simplify to get our final answer. Now the first part, 2 times 25 over 4, ends up being 25 over 2. But we need to make sure it's something over 4, so we're going to turn it into 50 over 4. And now we've got 50 over 4 minus 25 over 4 minus 48 over 4. Now, which gives us the following answer. y is equal to negative 23 over 4, which means our vertex is our axis of symmetry and our y value that we just calculated. So we end up having the vertex being negative 5 over 4, comma, negative 23 over 4, and we're done. Now, your problems are posted online. I need you to do a set of questions for each. Good luck. All right, guys, so basically let's just go over this one last time. So we're going to have a decision tree file that I have set up for you that you can use. You can print it off and use it to help you do the quadratic formula problems in our current lesson. Now, for this task, you're always going to be given an equation that looks like this form. Y is equal to 2x squared plus 7x plus 6, right? Now, sometimes you're going to set the y value equal to 0, or you may be looking for a specific y value. For this case, what I did was I let y equals 5 to kind of show you what would happen. If we ever have that, all we have to do is we make sure all our numbers, all our variables, everything is to one side. So it looks like y is ax squared plus bx plus c is equal to 0. Okay. Now, when we do that, we move all our information over and we collect all our like terms, and we have something that looks like this. Now, once we've done that, the next stage of our problem is to take our problem and compare it to ax squared plus bx plus c equals 0. Now, what is interesting about this is once you've compared that, you've got your A, your B, your C, then what we do is we go and sub all this information into the discriminant. Now, you calculate your discriminant by plugging your number in. In this case, you got 7 squared minus 4 times 2 times 1, and you get 49 minus 8, which is 41. Now, based on this information for the b squared minus 4ac, you'll notice that there's 3 choices. If b squared minus 4ac is bigger than 0, okay, so that's this one here. That's the most important one because we normally see something like this where we have 2 solutions, okay? This is the thing that you'll normally see. You'll have 2 solutions. So your parabola either looks like this. It opens up and crosses the x-axis at 2 points, or it opens down and crosses the x-axis at 2 points, okay? Where the vertex is above or below, like so. Now, if b squared minus 4ac is equal to 0, what you need to do is you basically say, you say there's one solution, and then you go on to step 5, and we do the same for the first part as well. Once we get to our b squared minus 4ac is less than 0, we just stop our calculations and say, yo, forget it. We're not doing anymore because we cannot calculate the square root of a negative number. And remember that b squared minus 4ac is going to be in our equation for our actual quadratic. So now we're going to sub all that information into this quadratic equation here. So now what we're going to do is we're going to take a moment and we're going to basically substitute this information back into our equation. And when we've done so, we know that A, B, and C are these values here. And the values are A is 2, B is 7, C is 1. Now, we already know what b squared minus 4ac is. So what I want you to do is I want you to use it in the equation because we've done the calculations properly. So now, we plug that in and say b squared minus 4ac is equal to 41. We're going to sub that into our solution, and we have x equals negative bracket 7 plus or minus the square root of 41. divided by 2 times 2. And simplify as much as we can on our next line. And then what we have to do is we have to take that problem and we split it into 2. Sometimes you have your square root of 0. Square root of 0 is nothing, so you can't do anything with it. So there's only one solution. But this time you have the square root of 41, which you cannot get a nice number for. You're going to get a decimal. So what you're going to do is you're going to leave it as 2 possible solutions by splitting the solution. So in this case, you have x is equal to -7 plus root 41 divided by 4, or x is equal to -7 minus the root of 41 divided by 4. And that's it. You're done. We call this version of our solutions, we call them exact solutions. Okay? So if I ever ask you for exact solutions, make sure you just leave your fraction to be something like this. And when I want the rounded solutions or approximate, all you're going to do is you're going to punch that in your calculator and get the decimal to 1 or 2 decimal places. That's it. Now, what I'd like you to do is I'd like you to make sure that you take this task seriously, because this is something that you need in grade 11.